Hello once again, dear children. We've progressed well through your syllabus. We're now at the point where we're looking at the response of plants to different stimuli in the environment. And the different stimuli that we're going to be looking at, my darlings, is the stimulus of light and the stimulus of gravity. Stimulus of light and the stimulus of gravity. Okay, and these stimuli, my darling, will be in response to a plant hormone called auxins. And you'd find that most of your questions on this section are on auxins. That is the first plant hormone we're going to be learning about. But what I'd like to do first is to talk about the other two plant hormones, which are not mentioned in this text that I'll be going through. Sorry, my babies. And those two other plant hormones are gibberellins. I hope I got the spelling right. Gibberellins, and the other one is abscisic acid. Now, questions are normally asked about these in multiple choice or in your A only, B only, but I've seen questions on graphs that are linked to gibberellins. So it's nice to learn about gibberellins in detail and abscisic acid, so you don't only think that they're going to be asking you about auxins. So let me do that first, and then I will look at auxins. So let's use this whiteboard and write a bit about gibberellins and auxins. So when it comes to gibberellins, my dear children, I teach children to remember this by the mnemonic FRED. F-R-E-D. Each one of these stands for a particular function of gibberellins. F stands for it stimulates, let me put this in small letters, my darling. It stimulates, I'm not going to write this in full, the development of F, flowers. Are you with me? R will stand for stimulate the development of R. What do you think R? Fruits. E is the one that they normally ask you about. It stimulates the elongation of internodes, and by so doing, and thus, what would it do? And thus it increases the length of the stem. Now, just in case you don't know, what is an internode. An internode, my dear children, I just want to draw it here so I don't go out of here. An internode is, it just made me go out. It just kicked me out. If this is a sugarcane stem, that which you eat is a sugarcane babies. Okay, so that is a node on a sugarcane. That's a node. This area in between is called the internode. Let me put another node here. Okay, so if the internode had to increase in length, of course, you would increase the length of the stem. So if that was where the node was and that area has increased, so you got there and there, your stem automatically gets longer. Okay. Good, as long as you understand that. And D, this is the thing that they almost always ask you about. It takes your apical buds, apical and terminal buds. Oh, let me not say terminal. Apical and lateral buds, and the seeds out of dormancy. What is dormancy and who puts them into dormancy? Who puts your buds into dormancy? Who puts your seeds into dormancy, my darlings? Who puts them into dormancy is that third hormone, and that is abscisic acid. So abscisic acid, it makes the apical and lateral buds and seeds dormant. Why? So that the plant or the seed, whichever one you're referring to, can survive adverse conditions. What does adverse mean? Really bad for the plant. Like winter. With winter comes extreme cold. With winter comes a lack of water. Right now we are in a period of winter. Okay, so abscisic acid wants to ensure the survival of this particular species. So apical buds are buds which are found. Let me just draw this again. So if this is your stem, like so, and your stem, if you've been watching plants and all that there, if you're an observant child, you'd find that the tip of the stem is always pointed. Now, this pointed tip here is called the apical bud. Apex is tip. So that is where you have your apical bud, my darlings. And this is actually where you have that first hormone that I was talking about. And remember, what was the first hormone we were talking about? Auxins. So auxins are found at the tip of the stem and the tip of the root. Those are where you have your apical buds. So what abscisic acid does, it puts these apical buds to sleep. Because if there was growth during winter, you do not have enough food to support the growth, because photosynthesis is decreased during winter, and you won't have the glucose available to provide the energy for growth. Thus, you'll be using up your stored starch, and that would cause the death of the plant. Lateral buds are found in here, in the stem itself, and they give rise to branches of the stem. So you also put them off to sleep. Seeds themselves must never germinate during the winter, because if seeds have to start to germinate, it is the cold that will kill off the germinating seed. There won't be enough water to support the germination of the seed. So abscisic acid is such a clever hormone. So it makes your buds dormant, it makes your seeds dormant. So as soon as those adverse or bad conditions are over, who comes along? Gibberellins, and says, okay, let me give you the kiss of life and wake you up from your dormancy. So it takes the apical and lateral buds out of dormancy, and it takes your seeds out of dormancy and prompts the germination of seeds. That is why you would find that related to gibberellins, they always talk about germination and the role that gibberellins will play in germination. Because what gibberellins do, they stimulate germination. They will stimulate germination. You know, the more the gibberellins, the more the germination of the seed that there will be. Why? Because they are able to stimulate the conversion of starch in the seeds to glucose, because you need energy for germination. So because they convert starch to glucose, or stimulates the conversion of starch to glucose, that is how they are able to support germination, because the glucose will now give you the energy for germination. And that is why, once again, if you're observant and if you can remember in primary school or maybe in early high school, they asked you to germinate seeds. Or if you've never done it, try doing that. Take a few bean seeds and put moisture in the cotton wool, put them between two pieces of cotton wool and put them into a dark cupboard, because darkness is important for germination. Because where do seeds germinate? In the ground, babas. In the ground, there's no light, there's darkness, so you simulate the same conditions for germination. And you'll find that as the seed germinates, the size of the seed decreases. why does the size of the seed decrease? It's because the stored starch in the seed is being converted to glucose. And if you are removing your stored substances, of course, there'll be a decrease in size. Like even me too. If I had to do exercise to remove my stored glycogen and stored fat or decrease them, I would also decrease in size. I'll get to it in time. Okay, my darlings? So those are the functions of gibberellins and abscisic acid. Good. So now let's go back and look at your functions of auxins. Okay. So auxins are very important, and as I said to you, they are produced at the tip of the stem and tip of the root. Okay, and the normal reaction of any plant organ to light is called phototropism. It's the growth of a plant stem towards light would be positively phototropism. The growth away from light would be negatively phototropic. So tropism, papas, is the growth or a turning movement of a plant or a part of a plant in response to an external stimulus. In this case, the two stimuli that we're looking at, oh, sorry, baby boys and girls, what did I now do? The two stimuli that we're looking at when it comes to auxins, the two stimuli are light and gravity. So we do know that stems grow towards light and roots grow towards the ground. Are you with me? Once again, stems grow towards light, roots grow away from the light, and they grow towards ground. So a general term for the growth of a part of a plant or the turning movement of a part of a plant is called tropism. But a specific term where you talk about the growth of a plant or a part of a plant in the direction of a light source, that is phototropism, because photo means light. And a specific term for growth of a plant in response to gravity is called geotropism. Okay? And both of them are brought about by auxins. And where are the auxins produced? At the tip of the stem and tip of the root. Very often they talk about, my darlings, very often they talk about a stem being positively phototropic. In other words, it'll always grow and seek out the light, phototropic, and negatively, you tell me what? Geotropic, okay? So positively phototropic, negatively geotropic. So it'll grow away from the ground. And then when we're talking about roots, the roots would be the complete opposite, wouldn't they be? Roots would be, yes, positively what? Positively geotropic, because they love to grow towards the ground, because that's where they're going to get their water. And they would be negatively phototropic, so they will grow away from the light. Now we will be examining all these growth movements of your auxins, and then we'll be looking at the other functions performed by auxins. Okay. So let me begin by saying, under normal circumstances, when the root receives, when the stem receives uniform light, that means light from all directions, then the stem will grow straight up. The stem will grow straight up. Let me just try and, sorry, my darlings, increase this here. So, first of all, auxins are produced at the tip of the stem, and they move down evenly and become evenly distributed on all sides of the stem. Even distribution of auxin brings about even growth or equal growth. So therefore the stem will grow straight up, seeking out the light, because it needs the light for photosynthesis. And also if the stem grows straight up, It'll be exposing the flowers so that the insects can come along for pollination. You know, so there's so many advantages to the stem growing straight up. Okay, so when there is even distribution of light, or what we call uniform light, the stem will grow straight up because there is an even distribution of auxins. Now, what would happen if there's an uneven distribution of auxins? And what would cause it? The uneven distribution of auxins will come when you don't have uniform light, because you have the even distribution of auxins bringing about equal growth when you have uniform light. Okay? And uniform light will cause this even distribution of auxins. So when would you have the uneven distribution of auxins? Let me just not distract you from what I'm doing now. Now, the uneven distribution of auxins will come from having an uneven distribution of light. So when the stem is exposed to unilateral light, light coming from one side. So let me just draw how we can do this in a laboratory situation. In a laboratory situation, for example, I can have a box. Okay, I can have a box, and what I will do, the box will cut off light, but I'll have a hole created, and I will now, I wonder if I can do a circle. Let me just draw a heart. Let me draw many hearts. So here I will have light coming in from just one direction. So from this light source here, which is a heart light source, okay, light is coming in only from one direction. So I'm controlling where light is coming from. So here I've got light coming from one side that is unilateral. Uni meaning one, lateral meaning side. Okay, so when the stem is exposed to unilateral light, the auxin concentration will be high on the dark side. So if this is my stem, okay, and that is my tip of my stem. So under normal circumstances, there'll be an even distribution. When there's light coming from one side, the auxins move over to the shaded side. They move away from the bright side. So when stem is exposed to unilateral light, because the auxins move to the darker side, there will be a higher concentration of auxins on the shaded or the darker side, and a lower concentration of auxins, say that, my darling, and a lower concentration of auxins on the brighter side. Because sometimes they give you marks for just talking about that. Sometimes they give you marks for talking about both of it. So cover all your bases. So therefore, there will be a higher concentration of auxins on the brighter side. And in stems, a high concentration of auxins stimulates growth. So there will be more what they so-called cell elongation and more growth on the brighter side, less cell elongation and less growth on the darker side, causing the stem to now bend. It will now bend somersua and will move towards the light. It should be more towards the side, okay? You can get the gist of what I'm saying. So no more will the stem be growing straight up. It will now be bending towards the source of light. That is how you demonstrate the bending movement of the stem in response to light, is when a stem is exposed to unilateral light, okay? So this is phototropism because it's responding to light. Okay, good. What would happen in roots? What do roots respond to? They respond to gravity. And once again, let me just take off all of this here, papas. Great. When it comes to roots, they will also produce your auxins at the tip of the roots. and they move up evenly, your auxins, bringing about equal growth of the root in all sides, so the root grows straight down. That is geotropism, growing straight down. But what would happen if I take that same root and I don't place it in its usual, like usually the root will be like that way and growing down. What would happen if what would happen if the root was placed this way? In other words, it's like a pot plant and the pot plant fell on its side and the root is now horizontal. Roots are never horizontal, it's only when there's an unusual condition. So when the root is placed like this, through the force of gravity, the auxins, which they were normally evenly distributed, the auxins from the top will now drop to the lower side. So there's a higher concentration of auxins on the lower side of the root and a lower concentration on the upper side. Now, the unusual thing about auxins in roots, a high concentration of auxins here inhibits growth. In stems, a high concentration of auxins stimulate growth. In roots, a high concentration of auxins inhibits growth. So therefore, there will be more growth on the upper side of the root and less growth on the lower side, now causing the stem to bend and grow downwards, seeking out the ground and in response to gravity. So roots respond to gravity by growing towards the ground. Okay, my darlings. So in case you tell me, but ma'am, what would happen to a stem if a potted plant was knocked over? If a potted plant was knocked over and this is now a stem, yeah? This is now a stem. STEM. By the way, what was this? This was showing you the response of a root. So the root bent and grew downwards. Okay, what would the stem do? Remember I said here, my darlings, when the root was placed horizontally, the auxins through gravity fell to the lower side. So there was a low concentration of auxins on the upper side of the root and a high concentration of auxins on the lower side. And I said a high concentration of auxins in the root inhibits growth. Yeah. So the upper side will grow more, or there'll be more cell elongation on the upper side of the root and less cell elongation on the lower side of the root, causing the root to now bend and grow downwards. This is what we call uneven growth. So in a stem, if the pot plant was knocked over, you didn't notice it, what would the stem look like after 2 or 3 weeks? Let's see what happens. Once again, there was an even distribution when the stem was upright. When it was knocked down, also through the force of gravity, sorry, let me just take this out. This was not supposed to be here. Also through the force of gravity, my darlings, you would find that your auxins will drop to the lower side. The auxins will drop to the lower side. You can't say it will drop in the root and doesn't drop in the stem. My God, that will be absolutely illogical. So the auxins drop to the lower side of the stem. So that means the upper side has got fewer auxins and the lower side has got more auxins. So what does a high concentration of auxins do in a stem as compared to a root? Remember, a high concentration of auxins here inhibits growth, but a high concentration of auxins in the stem will stimulate growth. Therefore, the lower side will have more cell elongation and more growth as compared to the upper side. So this one will grow more, causing this stem to now bend and grow upwards, seeking out the light. So your stem, it won't look that hideous, my darling. The stem will now bend and grow upwards, seeking out the light. That is what your stem, so this is what will happen in your stem, and that is what will happen in the root if either the root or the stem was placed horizontally. Very important to remember this because they give this to you in a variety of questions, investigative questions that they will pose to you. Brilliant, my darlings. I hope you understood this part of auxins and its role in phototropism and geotropism. And the last part of the role of auxins is the role of auxins in what they call apical dominance. They normally ask this of you in more than one way, you know. Apical dominance is where the auxins at the tip of the stem regulates the growth of the lateral buds. Apical dominance. It regulates the growth of the lateral buds. Now, lateral buds give rise to branches. Okay, so if this is a stem like so, let's see what a curly thing would give me. If this is a stem like so, my darlings, you will find that branches will come out of the stem like this. Now, these branches emerge from what we call the lateral buds. Now, notice as I am drawing these branches, I'm making the branches further away from the tip, longer and longer and longer. That is because that apical bud over here regulates the growth of the lateral buds. The closer the lateral bud is to the auxins at the tip, the more control it will have over these branches. So these branches grow less compared to the branches away from the tip, thus giving a, well, most trees this typical shape, this conical shape, which is very important in getting all your leaves exposed to sunlight. And in trees that grow in the snow, it ensures that if there are big branches at the top, they'll become laden with snow and kill off the rest of the plant, you know. So the smaller ones, if the snow falls, it'll fall down and get onto this and it'll fall down to that or whatever. So most probably the lowest of branches will die off. You don't have to worry about that because you'll still have the others to carry on with the growth of the plant and the functioning of the plant after the snows ease. So apical dominance is where the auxins at the tip of the stem regulate the growth of the lateral buds. And the minute you remove the tip, let me just remove the tip, my darlings. The minute you remove the tip, oh sis, I removed the rest of the plant. Oh goodness me. Let me put the rest of it in place. So the minute you remove the tip, then there is no control of these lateral buds and they will all grow equally. All of them will grow equally in length. Whether they were close to the tip or not, because it's like you. When teachers are away, you all are equally naughty. When teachers are there, some of them will be naughty. The other ones who want to be in the teacher's good books will not be naughty. The moment the teacher is removed like that, then all of them are naughty, like that. So apical dominance is where the auxins at the tip regulates the growth of all the lateral buds and therefore regulates the growth of the branches in a tree or a plant. Good, my darlings. So we looked at the role of auxins in tropism and we looked at the role of auxins in apical dominance. When I do see you next in the next video, we will be doing a variety of questions and lots of beautiful investigative questions on the section called plant hormones. Until then, enjoy. It is fantastic being in grade 12. It is the threshold to the rest of your life. Enjoy and do the best that you can. God bless you.